Thank you all for joining today for Building Simple Circuits with Common and Accessible Materials with Walt Silva from Schoharie Mohawk Initiative for Science and Technology. Walt is the president and founder of Schoharie Mohawk Initiative for Science and Technology, which is a team of engineers, educators, and technology specialists who are community-minded individuals with a passion for sharing their years of experience with the next generation of innovators. Walt received his bachelor's degree in electrical engineering from Rensselaer Polytechnic Institute and his master's degree in computer science from Union College. For almost 25 years, he's been involved in submarine development, originally working at Bechtel Plant Machinery, Inc., and then at Knolls Atomic Power Laboratory, where he currently works as an engineer manager. And previously, Walt served in the U.S. Navy and Navy Reserve before being honorably discharged. Walt currently lives on a small farm in Delanson. Hopefully I pronounced that right. So I'm gonna send it over to Walt to get started. And if everyone wants to just say hi, wants to say hi in the chat and where they're from, that'd be great as well too, right?
Well, thank you. Hopefully everyone hears me. Thank you, Abby. Yeah, so I I'm going to present some slides, and I'm also going to show some material or show some actual pieces of things that we do as part of our program. And if you have a question or anything, please stop me and ask the question. I'm really just for me, I truly believe it's important to share as much information with folks. So kind of like Abby mentioned, I don't do this professionally. This is more of a passion. Um, Working as a engineering manager in the area I do, I see a lot of engineers come through, and sometimes there are things like, oh, I wish, in school they had done this or they had taught them this. So some of the stuff that I see, we try to actually incorporate as part of our programs. I'm going to do we're going to just go with some simple electrical circuits. And we're going to talk about really more from a DIY perspective. Um, and we like, and a lot of our programs are what I'll say DIY. And we'll talk a little bit about some of the kits that are out there. Kits are great to get things going. But one of the things we find that's really important from an engineering perspective is that doing DIY, each kid, each student's project does not look the same. However, it shows them that it doesn't have to be the same for it to work the same way. It gives a great opportunity for kids to fail, which is, we think it's really important. Otherwise, that's really where the learning is, and really, how do you recover from a failure and go forth? So let me just go through. So just our agenda, quick intro and background. Talk a little bit about some of the commercial options. We do have some that we use as well. But then the DIY ones, we're going to talk about paper circuits, circuit cubes, something called scrappy circuits, squishy circuits, and then any questions folks might have. So again, as Abby mentioned, so the Schoharie Mohawk Initiative of Science Technology, we started about, it's hard to believe, it's over a decade now. And it really started something as small where, one of the teachers asked myself and another gentleman about working and doing a robotics program at our local school, which is Dwaynesburg. We have roughly 650 kids, K through 12, so it's a fairly small rural district. And then we got asked questions about doing summer program, and then that's really how it started. So we are, like Abby mentioned, engineers and trades. One of the things we value and we think it's important for folks to recognize is that the trades and technicians and having that skilled labor force is just as important as having engineers and professionals. A lot of times when we do development, the engineer will design something and put it together, but the technician is the one who really makes it work. He or she is the one that's got what I would say more of the hands-on practical knowledge. So we recognize that that's an area that we try to focus on, and even some of our newer programs where we're getting into welding and so forth. Um, so we do offer programs. We do different things K through 12, and we do partner with different groups and organizations. And part of that is recognizing that not one group can do it all. So, coming out of this, if there's things that you're interested in maybe partnering with us, we'd be more than happy to talk about. So what our programs are, we don't really focus on the technology of the platform. We really look at it as a means to an end. It's always changing. The real thing is, how do you encourage critical thinking? A lot of our programs, we have students working at least in teams of two. Makes them, how do you work through things when it's not exactly the way you want things to be? How do you collaborate? How do you document things, and how do you present? How do you, talk about the things you found out? And again, building self-confidence. And we, again, failure is okay, and we'll see things as they go, and folks, when we know it may not work, and we just let the students progress, and it really is an opportunity for them to understand. And then again, how do you recover from failing, right? That's an important skill. But in the end, we do want them to have fun. So we try to keep it light. And one of the things we also try to do with our programs is that each team or student can bring home whatever they've worked on to maybe work on it further, or try to expand maybe some different ideas from concepts they learned. Okay, so I guess before we jump into the different circuits and all those items, like, what experiences do folks have working with, I'll say, circuits or electricity or anything like that, and how did you um, proceed? I'm just curious to understand.
Also, people can write it in the chats too if you're got crazy backgrounds or something. I know some people are in session or something. So mention it in the chat too. And Walt, I'm sorry if I missed it. Can you also explain STEAM with the two A's to everyone?
Oh yeah, so yeah, so you hear STEM, right? Science, technology, engineering, and math, and then you hear STEAM, science, technology, engineering, arts, and math. So, and then we add another A, and part of that is the fact that we added the other A is agriculture. Um, People, again, out where we live, and probably maybe some of the other areas. I know, we were talking to Nancy, Ithaca. Our agriculture is a huge part of the community, and there's this, I think, in some instances, this concept of, you know the way, you have animals, you have plants, and there's, you just put the seeds in, they grow, the animals do, right. There's no really understanding that there's a lot of technology that goes behind agriculture, and doing a lot of things that the farms, and both large commercial and some hobby smaller farms do, that really are based on technology. You've got drones that are out looking at livestock. They're doing looking at uh, growth patterns in the fields. You've got, some of them are delivering fertilizer. So for us, we think it's really important that to try to draw that connection, that the things that we're doing is very relevant to our community as well. So that's why we put the other A in there, because we think it's an important area, um, for our folks to make it visible to them. So the first things that are out there are these commercial kits, uh, and you may have seen them. There's snap circuits, which have a lot, and you'll see that there's actually a lot of correlation with some of the things that, from a uh, DIY perspective, that they use here. So snap circuits is the one that's popular. Another one's called little bits. And I, and I actually, hopefully, can you see that? Maybe by little bits.
Yeah.
Yes.
Yes, a little bit. Yeah, if you hold it up a little higher, we can see it all. There. Yeah.
Okay. So so yeah, so this is so we do use the little bits too because they are pretty cool. And I'll just show you real quick what it does. So you've got a battery that's hooked into a power supply that feeds a power supply. And what it is, it's just bits that are put together and they use magnets. So you can hopefully you can see there's little magnets in there and they actually go together and they can only go together one way. And each color actually has a like a meaning. Pink is like inputs, green is outputs. So if I were to slide this slider, you'll see hopefully that the LED will start turning on. Oh, if I just, all right, I'm gonna have to go there with my other hand here. Come on. So you can see that hopefully it goes on and it'll grow brighter. So this is a something that's provided by a company called Sphero. Um, and it has a lot of different components and it's really great. So I can even put like it'll have a buzzer, and I'll just do this real quick that you can put on, and you've got again different um, components, inputs and outputs that really again helps the kids understand circuits. And what's nice about it, it's pretty robust, so it doesn't end up, I'll say, getting burned out if you pull things apart and you don't have things turned off. So this is a great commercial product. Again, we use it also. But like I mentioned, we like to have the kids be able to bring things home, and because it gives them an opportunity to kind of see what they have and think about it, and can they do something different? And this is it's great pro kit, but it is fairly expensive. So these are the kits that we keep keep with us. So how do we get to that next step, right? Doing kind of something similar, that flexibility, while not being too crazy on cost. So DIY kits. So I was, if you're interested in doing it, there's so many different ideas on the internet. And I will have one of the slides has different websites as a starting place for you to go take a look at. But really part of this is taking that information and how do you expand? And I'll show you one instance where we took an idea and we actually expanded it to make it a more advanced project for our older kids to go do. But a lot of the stuff that I mentioned here, it really consists of, you'll find copper tape, coin batteries, paper and cardboard, LEDs, paper clips. So again, I do apologize if I go off camera. I've got my things scattered here as I want to pull them up. So for instance, I've got a big, this is one of a few things I've got, but here's like copper tape. A lot of this copper tape is similar to the copper tape that you would find in a um, like a box store it's called like slug tape. And you put it down so the slugs don't like the feel of this of copper, so they won't cross the boundary. So if you're protecting plants, you can use it's that. Um, a box of the different LEDs. So these are a smaller box of LEDs. Again, you can get these off of Amazon. We actually use same with you buy a bunch of these coin batteries that we also use. We do have like alligator clips that we use, and you'll see where we use those in one of our projects. Uh, what other ones I want to? Oh, aluminum foil. So I think everyone knows what aluminum foil, so I won't show that. But just regular paper clips, and then a bunch of these binder clips we use for one of our programs. So a lot of a lot of the similar concepts are similar, but how the material we use, how we put it together, really distinguishes a lot of the different programs. And again, some of these things, for the most part, are readily available at the grocery store. or a dollar store, or you can find them on Amazon, and they're pretty inexpensive. All right. And again, if folks have questions, please let me know. So this is I got a bunch of this material. It's up in my attic, and whenever we get ready to do a program, I put all the stuff together, and we figure it out and make sure we've got everything we need. So this is the components that make up these DIY kits that we have the students do. So the first one we'll talk about is this thing called paper circuits. Um, if you go on the internet and you look for paper circuits, you'll find that they have these templates, and really the crux of them, and I'll show you different things, is having what we call a diagram. In many ways, it mimics what we call a schematic diagram, basically what the layout of the circuit looks like. But for this one, and sometimes I should say the schematic sometimes doesn't necessarily represent physically what the layout will look like, but these do. So it makes it really easy for the students to basically follow the lines, and you'll see that for this one, it's a simple circuit, just a circuit where you have a battery and a LED here. So you have an LED here, and you talk about your batteries, and we'll show you. So I've got this is what it looks like. This is the one we use as an example for students. And let me just grab. And this is what the sheet looks like. Hopefully you can see the whole sheet. But this is what the sheet will look like to the students when we hand it out. And we talk about, the positive, negative for the battery, and we talk about what an LED is, why it's important from a plus and minus. So we try to talk through a lot of the concepts, but we don't, again, it's important for them to understand, but we try not to dwell on it too much, because the idea really is for them to kind of understand, but try it out. So this one is what it is. This is what it looks like, and I'm gonna hopefully it was working before I got on, so hopefully there it is. Hopefully folks can see it. The green light.
Yes, I can see it.
Okay. So really that circuit is just copper tape that we had put together and one of the coin batteries, and it just flips right over. So this is, like I said, we usually do this for our younger students. Anywhere from third to fifth grade, we will do these with them. And then there's other variations. So depending on how complex you want to go. So this one is actually kind of cool. This is a traffic light. And again, similar concept. You've got the layout using the copper tape, and then maybe it's a little hard because these LEDs are clear, but you have clear LEDs here, and then you actually have a switch right here that you use via a paper clip. So if this works, hopefully this will work. Oh, come on. Nope, it's not going to work. Hold on. Try this again. Oh, maybe. So hopefully folks can see that the yellow one is working.
Can you
I've
hold it up
got
just a little bit higher? Perfect. Yeah.
yeah. So the yellow one's going, and see if I can get the red to work. Yep, there it is. The red is now on, and I actually got the yellow because I'm crossing. But what you have there is a switch that we created using the paper clip. So this is again one program that we do, and again this is typically for some of our younger students, to go and understand what they are, and it doesn't necessarily always work. Again, part of it is as they put the LED down, the copper tape may not adhere perfectly, so it may work intermittently. So it helps really also to help them troubleshoot and figure out why is things are not, again, working the way they would think they are, and it helps them troubleshoot. So that's so this paper circuits is one program we do, and what
Well,
we did. Yep.
there is a question. Louise said sometimes when using copper tape, the LED doesn't work. Any suggestions?
Yeah, yeah. So one of two things will happen with LEDs. They being a diode, the electricity can only, and I apologize if you know this, but the electricity only can flow in one direction, right? So if it doesn't work, typically what I'll do is I'll have the student take the LED off and just rotate it, and that will fix it. Thing to look at is when you put the LED down, the long leg should always be pointed toward the positive part of the battery, and the negative should be pointed to the negative part of the battery. And the positive has a longer leg also. Then, if that doesn't work, and you know it's oriented in the right direction, um, we used to use just regular plain regular tape um, on there. Now what we do is we take the copper tape and we use the copper tape to put down the legs. So this way I have better contact, instead of just using the regular clear tape. Okay. Hopefully that answered your question.
Yeah, she said, thanks, that's helpful.
Okay, great. So what we did, hopefully maybe folks are familiar with the game rock, paper, scissors. So what we did is we actually created a rock, paper, scissors version of this, of being able to use copper tape and so forth. So this is the rock, paper, scissors version that we have. And you can see hopefully you can see there's a lot more wires, and they have different colors. And what's cool about this is that this actually introduces students to the idea of circuit boards, very simple circuit boards, because these connections, even though they go over each other, we actually have to separate them out so you don't get short circuits. So it teaches them that, like, when you look at a board in a computer, or any, I'll say, consumer device now, they actually have different layers where the wire traces go through, and they actually build a very simple board by using clear tape to act as an insulator between the copper tape that sits on top of each other. So this is again a little more advanced topic, but it is pretty neat. And then at the end, they can actually play rock, paper, scissors. Okay. So we those are that's the paper circuits. And again, I'll move on. Next idea is the idea of what we call circuit cubes. Um, so this concept, it came from a company called Brown Dog Gadgets. And this is, the other one, it was kind of a whole, you had to build the copper tape together and put it together, and it didn't really give you an opportunity to, I'll say, take apart modules and put them together like the little bits that I demonstrated earlier. This does. And here's so these are examples that we have the students build. So this one is the one that's used for the battery. This is the LED one. And what's inside is that you've got these copper connections, so this allows the electricity to flow. But what you can't see internally is that there's two magnets inside and two washers that are taped inside. And what that allows it to do is it allows the cubes to connect using magnets. And you can see here that, hopefully you can see here, is that you've got the battery, and I connected it to the LED. So what's also neat about this one is that, let's say I do it, I just reversed the polarity of my battery, and you can see that it doesn't work. So now, oh, it didn't, I don't have the right polarity. Now I do. So it gives them that great opportunity to, you know, again, troubleshoot, but it gives them the ability to create now modular circuits. So I've got the battery, the LED, and if you can see really close, I've got another cube that's got a little switch here. So what I'll do is when I press on that, the light should go on. Assuming I got this in the right. So you can see me pressing, and now I've got the battery, and that's allows them to do that. And then again, I can change it, and I can put my, hopefully my place will, well, let me try to make sure this is connected. So I've got a buzzer here. And that's the other, oh, it'll work. Was working. Oh, it's not working now. I'm not sure. So that's part of it, is troubleshooting with the kids, because this is just, again, paper, so it's not, the connections aren't perfect. So it, again, oh, there we go. Hopefully everyone heard that. Uh, so now let's try to see if this works. So that's got the switch. So this is, again, another. So these are, we typically do with some older students, because it does require a little more, uh, I'll say, fine work to make sure that the tape goes on there, make sure they've got everything, the bat, the magnets and the washers put in the right place. So what Brown Dog does is they actually have templates. So the students will cut them out, put it together, and they'll show where the copper tape goes. And they do have different ones. So they do like have an LED one, um, and they have a battery one, and there's a few other, I'll say, predetermined ones. But then they have a general one, which was the kind of what this one was. So there's a one that just basically shows you where the tape paths go, and then you can just change it with whatever you want it to be. So here I put a buzzer. So as long as I've got two connections that flow into my paths, I can put anything on here. So I can do a buzzer. I could do like a vibrating motor. Um, the other item I could do is for a switch, um, I could actually, instead of having this physical switch here, I can do something what they call, I can put like a photoresistor across that, where depending on how light or dark is in the room, will allow a certain amount of electricity to flow through it. So it really gives you a lot of opportunities and avenues to kind of update and create whatever you want to do and show the students and have them do. And again, we typically do things that we know are going to be annoying at home, that mom and dad are going to like, why did you do that? Because that's what the kids love to do the most. So yeah, we do a lot of things with noise, like this one, and then we do a lot of things with the lights and stuff like that, because those tend to be, very visible, not visible, but very evident to the students that it's working. So Circuit Cubes is another program we run.
We do have another question. Jamie,
Yep.
do you have recommendations for when the copper tape doesn't stick?
Um, Typically, I've never had. So if the copper tape doesn't stick, probably one of two. One, maybe you still have some of the backing on it, because it is hard to peel off the tape. So I know at times Sometimes I will get I'll actually peel it and I'll still have like a piece of paper on there. So if you don't see any of the copper tape coming through the other side, the sticky side, then that might be one thing. Um, Typically, if it's not sticking, I'll just take it off and I'll rip off another piece and just lay it on top. So that's the other nice thing about copper tape is that I know that times that when you buy it, they say that the conductivity of the copper tape on the sticky side is maybe not as good. I've found that I've never had a problem. I bought copper tape at various places from Amazon and in other areas, and I found that if you need to, I'll say piece together a um, a trace um, of copper tape, it works really well. The other thing we try to do is, when you'll get these creases sometimes on the copper tape, I just take like the flat end of my finger, my fingernail, and I try to get rid of all the creases that are in there. Just try to smooth it down as much as possible. That also helps with um, the conductivity and the connectivity of the copper tape. But yeah, if you just can't get it to stick at all, to me that sounds like it's a probably you have a bad roll or something like that. Okay. So circuit cubes. So the next one is called scrappy circuits. And this one, which is different from the other ones, we don't actually use any copper tape for this one. So this one actually uses uh, the binder clips that I had shown earlier. And I've got a series of them right now. So here is the battery connection, and this. Let me put my battery down here, and literally, it's just a two binder clips that are on a piece of cardboard, and I just got to make sure that my negative is touching the bottom here, and that my positive is touching the bottom of this clip. The important thing with this project and where we sometimes run into the challenges is the fact that the black part of the binder clip acts like an insulator. So it's non-conductive. So what we end up doing is before we build any of each circuit, I give each student gets a little piece of uh, sandpaper, and we just take the sandpaper, put it in, and just have them basically do five sides one way, then flip it over and do five on the other side. This way this way we don't have to remember what side we ended up sanding because sometimes they'll put the paper clip down and they're like, oh, I don't know what side. So we just do both. So this way we don't have to worry about it. And uh, that is, and that's really the thing that we just have to make sure, and then just make sure that the connection is on there like that, and then the battery. And what's neat about this, again, similar probably to the cubes, is that a lot of the same things that the students have to do, they have to do for each one. So after a while, I go, let's start building the next one. And I don't have to say anything. They're already like boom, boom, boom. So they remember the process and it really works out well. So here, and then I use these alligator clips. You can get them fairly inexpensive at on Amazon. The other thing you can do, and I've done it, is you can actually build wires out of aluminum foil. And do I have that? I don't, I don't have it readily about, but basically if you see on the slide here, this slide here, I've done that. So all that is just basically some aluminum foil that's been rolled up, and the ends have been connected to paper clips. And you just hook those, and you can probably like open them up a little bit, like pull this out a little bit so you can hook it onto the end of the binder clips. And this works just as well as using alligator clips. I tend to just do the alligator clips because typically don't have a lot of time. This does take some time to build them, and like anything that they build, it it doesn't necessarily always work pristinely. So that's, I will say, I do take a shortcut there. But we every so often, if I have enough time, we'll actually build a couple of those so they can see that, even when they get home, they can keep on building. You don't need the alligator clip wires. All right. So so here's just a couple other ones. So typically, again, we've got the LED one. Very similar kinds of a setup. It's the two legs connecting to the binder clips. Uh, then here's another switch. So this is two binder clips, and what I've done is I've folded up the one paper clip, and it's not touching. And let's see if this works. Let's see. Hopefully, see if you can. So, and again, uh, there we go. So you can hopefully see the lights turning on as I do it, it turns on. So you can do those. This is the little photoresistor switch that I was talking about. That again, it's pretty inexpensive. You can get on Amazon, and a lot of these components are pretty neat in that you don't really. It doesn't matter what direction that you put them on. Again, the LED is the only one that really is kind of finicky. And obviously, I'll say, and the battery. But otherwise, it's really up to your imagination. So this switch here, this switch here is actually a magnet with I didn't use a washer. I have these little metal discs that you could put a wire here, and you have a wire here, and you just put it together. And what it is, you've got tin foil all around, so that helps allows the conductivity, and you've got like a magnetic switch similar to that you might see on Windows or something for alarm systems. So this is one of the switches that is a new one that we had built. And again, you leave it up to the students of ideas, and in terms of how do you have the electricity flow, and there's a bunch of things that they can create with the scrappy circuits. But this one, unlike the other two, don't use a lot of copper tape, or don't use any copper. That's better. Yes. So hopefully now folks can see it. There we go. Now actually I can see it. I'll stand up a little bit. So so I just have it on here. So this is again, the battery connection. And here is the LED. And then I've got my switch. And then hopefully as I push down on the switch, you can hopefully see the light. And again, some of this is, there you go. You can press down. And again, it's the binders clips really work well. Again, if it's not perfect sometimes, then I'll have the students go off and sand their connections down a little bit more. Um, but yeah, this is, like I said, is really nice because again, the copper tape is great, but it's probably a little easier to fix this problem than it is peeling off the copper tape and so forth. So I guess and then again, maybe, I don't know. So this is the magnet one. So this one would have a copper, it would have a wire here and a wire here. And again, this just has a flat disc, something that you'd even get like a punch out from the your is it, breaker box, for example, something like that. But you can buy them on Amazon. And then this is just, you can see there's a magnet that's just a regular ceramic magnet under here, which is non-conductive. And then I just put tin foil all around it, and it just comes together, and then it becomes another type of switch.
Thank you.
You're welcome. All right. And the last one I have is, let's go. All right. All right. So, okay. The last item is called squishy circuits. And folks probably, so this is called squishy circuits. And this is one I don't right now have an example. Oh, I don't have an example of that I can show you on Zoom. But I think the concept is similar to the other one. So this does not use copper tape. What it does is it uses two different types or you can have two different types of Play-Doh, basically. So this is something that you can actually make at home. And basically it's a dough, like it uses cream of tartar and some flour to in water to put together to make your dough. And this is the conductive. So this has a lot of salt in it also, which helps the conductivity of the material, and that serves as the wire. So instead of using the copper tape or um, using the alligator clips, you use the Play-Doh and do the same thing. And this is really great for even the younger kids, because um, the website that I'll give you, they do a commercial version of these kits, but you don't need to do it. The recipe that they use is provided. So they have a conductive version, which is what I'm showing here, and they have what they call an insulating version. So they have some of the Play-Doh that acts as an insulator. So you could actually put conductive, insulator, conductive, and actually have them sit on top of each other, and allows you to create different circuits and so forth with that. Um, we we ended up building our own kits, meaning that we bought our own power supplies. They have one here, power supplies. Our kits have LEDs. We also have motors that we bought, the LEDs we actually soldered connectors on so we could stick them into the Play-Doh. So there's nothing, again, that requires you to go off and buy something. You can go, a lot of the stuff you can go to, I say buy, but go to like Amazon and build your own versions of these kits, and do whatever you want to do. You're not, again, necessarily limited by the vendor of of this item or any of the other, yeah, for this item. So this is another one, squishy circuits. It's a great, again, really good for young kids, because you can get really creative with what you build between how you use the insulating dough and the conductive dough. Okay. Then let's see. So these are the websites. These are just, again, there's a lot. If you go on the internet and you Google like paper circuits or scrappy circuits, there you'll find people that have done these and taken to the next level of building and ideas. And I think that's awesome, because again, I truly believe it's important to share all these concepts and ideas, to make this much more accessible to students.